welcome to the Data Science. Thank you all for coming, and what we're trying to do is to thrive in this beautiful environment of all data, and all the brain today going to be like hopefully all together and make sure that we share beautiful ideas. So few admin bit before we start. So please either switch off your phone or put them on silence. You have in your bag the calendar event. So, but if you feel a bit lost or you have questions, please reach out to anyone that has this beautiful t-shirt, and they will be very happy to help you. There is water on the back of the room, so feel free to use them. So the data science, for some who it's the first time, is celebrating everything that is around data. And we aim to connect the tech community together and foster for sharing knowledge, ideas, and inspiration. So as you know, this event is free to attend, and we won't be able to do that without our sponsors. So thank you to Attest, Barclays, Bumble, CFC, Data Idol, Databricks, Deliveroo, Digitas, Direct Line, Dunhubby, H2O AI, King, Marks & Spencer, Open Credo, and finally CodeNode for sharing and giving us this beautiful room. So this year we will not necessarily handing around the mic for the Q&A, so I will ask you to use your most beautiful voice, loud, clear, but if you're not a tenor or baritone, I'll come and probably help you to repeat the question. So our first speaker today, some of you already know him. I could spot that when some of you come into the room, but hey. So welcome, Tom. So Tom talk today is about parallelization the Panda way, big data with Dask. So if you don't know Tom, Tom is Monsieur Super Geek Data. So it's a nice intro, right?
Yeah, but thank you. No, I like that.
Super Geek Data. And has role in statistics, data science, data engineering, and most recently, you are machine learning engineering with Saint-Gobain. Saint-Gobain being the world-leading company in construction and building material. So, 9 a.m., please put your hands together and give a very warm welcome to Tom.
Hello, everyone. Thanks for coming. I hope we're all enjoying the weather. I'm really glad to be presenting first before the room heats up and gets too uncomfortable. But hopefully, you know, they've got the aircon on. Hopefully, throughout the day, it should be a relatively comfortable temperature. So yeah, that aside, my name's Tom Ewing. I'm here to talk to you about parallelization the pandas way, data at scale in Python with Dask. So I'm going to go through a brief introduction. I'm going to tell you all about Dask, the background. We're going to go through some code and some examples about how you can work with Dask. And finally, a section on configuring Dask, which is really, really important. And then hopefully, at the end, we will have some time for questions. So about me, just to build on the introduction, I've worked in data most of my career. I've had roles in government, consultancy, startups. And as the presenter said, I'm most recently working at Saint-Gobain as a machine learning engineer. I've got a wide range of skills at the expense of depth in any one single thing. And at the moment, I do like delivering technical talks because at the moment my job doesn't involve a great deal of coding. So doing this kind of thing is an opportunity for me to pick up something new, learn it, and then kind of share it with the world, so to speak. Now, about the talk, as I mentioned, I don't profess to be an expert in Dask, but what I do like is finding easier and quicker ways to do things, particularly for my team and my organization. And Dask definitely falls into that category. I'm not paid by Dask, I don't have any affiliation with them, but I do believe in it, and I do think it's a really good tool. If you're the kind of person who wants to do stuff more efficiently in Python, then I think Dask may be for you. I've been quite selective about what I'm showing you, so there are bits of functionality of Dask that I'm not going to delve into. But if you like what you see, then by all means go away and explore those. And it's not a training session, so there is going to be code, but we'll not be diving into it too deeply. Everything you see is available on GitHub, and I'll give you the link to both that and the slides at the end of the presentation. Now, usually, before I present, I've run through the presentation at least 4 or 5 times. I know the timings, I know everything. I didn't get that opportunity today because I've been quite busy this week. And I thought, I'll wake up early this morning and practice it at like 4 or 5 a.m. So that way I'll come and deliver it and it'll all be on time and everything will be perfect. But someone else had other ideas. So my daughter Merin also woke up at 4:30 and she did not want to listen to me talk about Dask. She wanted to play with the toys. She wanted to get fed. So the talk isn't as slick as I usually would be, but hopefully you'll get the idea. And like I said, the code and the slides will be available at the end anyway. So just a bit of background about Dask. So if I had to describe Dask, I would say it's about large data workloads, just using Python, doesn't have any external dependencies, on your laptop, and it scales to virtual machines, cloud services, Kubernetes, and it's all in PyData style code. So if you write pandas, NumPy, scikit-learn, you will be able to write code using Dask. It was created in 2014 by Continuum Analytics, but now Anaconda. You may know them from releasing the Anaconda distribution of Python, and if you've installed that, then you've already got Dask on your machine because it ships with that. It's free and open source, and it's built, as I said, around pandas, NumPy, and scikit-learn, and it is quite widely used. And as a general rule, if NASA use something, it's got to be quite useful. Although it's probably not as widely used as Spark. Well, it's not as widely used as Spark. Just a quick show of hands. Has anyone here used Dask before? A few of you. Has anyone here used Spark before? Yeah, more of you. Okay. So before Spark released version 3.2, there was a really clear use case for Dask in that you could write pandas code and execute it at scale. However, and it turns out that not a lot of people know this, but with release 3.2, Spark have actually released a pandas API, so you can now write pandas code directly on Spark. And that did make me think, well, do we still need Dask? And when I was kind of coming up with the talk, there are still some really good use cases for Dask, and I think it's still relevant, and there's still a reason to use it. Interestingly, who knew that you could now write pandas on Spark? Like 3 of you. Wow, they need to shout that, because that's the biggest barrier to Spark, is having to use the PySpark API, which isn't very nice. So now you know you've got something. If you Spark users, you've got something from this talk already. So what's it good at? Well, it's really easy to set up, and it can improve. You can improve processing on your local machine. As I said before, it scales really well. So if your data becomes too big for your local machine, you can scale up to a more powerful cloud VM or a cloud service or a Kubernetes cluster. And as I said before, the API and data structures should be really familiar to you. To install it, if you don't have it already installed through Anaconda, it's as easy as this. You can either conda install Dask or pip install Dask. Once you've done that, it's set up, it's ready to go. You don't need to create a separate cluster. It will all operate on your local machine as quite seamlessly. Okay, so now we're going to delve a little bit into the Dask API. And as I've said before, if you can write scikit-learn, pandas, NumPy, you can write Dask code, mostly. Now, I don't want to delve too deeply under the hood and talk about what kinds of things are happening at a lower level, but it is useful to understand some of the terms. So we're going to have a brief go through those. So the first thing is the client, which is what you interface with to tell Dask what to do. The scheduler, which takes what you want to do and actually schedules it with the workers who are the things that actually execute the computations. Those computations are called tasks, and the workers are overseen by a nanny. So if for whatever reason one of your workers breaks, your nanny will come along, pick it up, dust it off, and set it off again. And finally, you have the cluster, which is a collection of system resources that all of this stuff resides on. Okay, so you don't need to know any of this for the talk, apart from a little bit about the client, but when you're dealing with error messages, it's quite useful to know what these mean. So the first thing you'll need to do is create a Dask client, and that's 3 lines of code. You import the client, you instantize it, and then you call it. And when you call the client, you get this nice little message that tells you you've got your client, it's running locally, and you get a link to the dashboard. And if you click that link, you will see the Dask dashboard. And when you execute a piece of code, you will then be able to see how it's being broken up and how it's being run on the Dask dashboard, which is really useful. So if you're not sure how efficient something is, you can start running it, flick over to the Dask dashboard, see how well it's executing, see how quickly things are processing, and then stop it, make adjustments, try again, so on and so forth. So it actually shortens the feedback loop of kind of trying to run efficient code, which is really good. All of the things we're talking about have rough Python equivalents. We're going to be talking about Dask data frames, which are really similar to pandas data frames. And if you've used Spark before as well, a lot of the concepts that we're going to be talking about are actually the same in Dask, just a different syntax. Dask bags, which are semi-structured data frames / lists. Dask arrays, which are NumPy arrays. Dask delayed, which is about the closest equivalent is probably Python's multiprocessing library. But that's all about parallelizing code. And finally, Dask ML, which is very similar to scikit-learn. The major difference is Dask will operate outside of your traditional memory. Now, what that means is, if in pandas you have a 20 gigabyte data set and you try and import it into your 16 gigabytes of RAM, it won't work, it will fail. With Dask, you'll be able to import that 20 gigabyte data set, work on it, execute stuff, and then write it out without a problem. That's essentially, I'm simplifying it, but that's essentially what out of memory allows you to do. And it also executes in a distributed manner across all of the cores on your machine. And basically, Python is a single-threaded, Python and pandas are both single-threaded, which means they basically operate on a single core of your machine. So my machine has 16 cores. I'm using one of them to execute pandas code. Now that's, again, an oversimplification, but Dask does these two things in parallel and manages them for you, so you don't need to worry about them. And that means that we can hold larger volumes of data and process it more quickly than if we're using base Python or pandas. In terms of the data I'm using, I've nicked two data sets off Kaggle, the flights data set and the store time series data set. I've times the flights data set by 20 to give me 116 million records, and the time series data set has a 1.7K time series, of which we're using 500. Okay, I am going to need to speed up a little bit, I think. So, Dask data frames. Dask data frames are very similar to pandas data frames. They're basically, if you use Dask, when you import Dask, if you import Dask.dataframe as DD, you can use that as a drop-in replacement for a pandas data frame, and you write code in exactly the same format. So on the left, we have the Dask data frame, and on the right, we have the pandas data frame. And as you can see, the only real change is that we're using DD from Dask data frame rather than pandas. So basically, change your code to pandas, change your pandas import to Dask, and you can write code largely as normal. Now, while the API is very similar, and a lot of the operations you'll be using are similar, there are some minor differences. For example, rename. In Dask, you have to provide a columns argument, you don't provide the axis, whereas in pandas you do. But that's, most of the kind of differences are kind of on that level rather than new functions, new methods, and so on and so forth. And also, Dask doesn't implement the full pandas API. However, most of the commonly used functionality that you will use is there. And I haven't found anything which I wanted to use and can't yet in Dask. So in terms of speed, well, how much quicker is Dask than pandas? So here we have some pandas code, and this is running on the 116 million records in the flights data set. Essentially what we're doing, we're reading some data in, and we're performing some pretty standard operations on it, filling in A's, dropping columns, creating new columns, a date time, group by, and then an aggregation. And in pandas, on that 116 million records, it took 5 minutes to run. In Dask, now you do have to make a few changes to the code, but that runs nearly 5 times quicker. So that ran in 1 minute, 13 seconds. So, and this is all on my local machine. You don't need to set anything up. You just need to install it, set up a client, and you've got a 5 times speed up. In terms of the changes, as I said before, we import the Dask data frame as DD, and we change the pandas references to DD references, and it will work. It should work with a few minor changes. The last thing is the compute function at the bottom. Now, Dask data frames are lazy, meaning that when we do all of this stuff, it's not executed immediately. So Dask kind of builds the data structure. It doesn't kind of, similar to how Spark works, you actually have to tell it, say, right now I want you to perform the computation. And you do that with the compute, either the compute method or the compute function. So in the example, we imported data into a Dask data frame. We aggregated the contents of that into the tab Dask data frame. We then called compute on the tab data frame, and we assigned the output of the computed tab to the tab out. And whenever you compute Dask, it will return a pandas data frame. So here, the only thing that we're actually loading into memory is the tab, which has been aggregated. So that's like 1 million rows instead of 116 million rows. It will compute the dependencies, so it's going to compute df20, but it's going to do that out of memory by shifting data in and out. And when you compute, when it will store the computed contents of what we've done in tab out, and that is a pandas data frame. Okay, so we could run compute on df20, but we would want to avoid doing that. So the big data frame where we perform all of our operations, if we were to call compute on that, we would load that into memory and chew up most of our system resources. So basically, to reiterate, when you run compute on a Dask data frame, you get a pandas data frame back, and you can do all of the stuff that you would usually do in pandas with that. So don't call compute on large data structures unless you have to. Here we've computed an aggregated data frame, and yeah, so ideally you want to call compute just once or a couple of times, only when you need to load the data into memory to perform an operation. As a general rule, a good Dask workflow is import the data, reduce it, transform it, aggregate it, and then either compute it or write it out. Now, when you write data out, it will trigger a computation, but it's not loaded into memory. What it does, it breaks it up into chunks and saves it into a CSV or a text file or a Parquet or whatever. So when we call the objects we've created, if we call df20, it will return an empty data frame. So Dask has done a little bit of computation on it because it knows what types the various columns are, but it hasn't actually filled it with data. If we call tab out, which is something we did compute, we get a pandas data frame. And you can also use head. So if you do .head, like you would in pandas, it will compute the first few rows. And there is all comparable processing to Spark in this. So if you use Spark, this workflow will feel very similar. So in summary, code's really similar to pandas. Dask data frames are lazy, and you have to compute them with compute. When you compute them, you get a pandas data frame back. Don't call compute too often, and don't call it on big data sets. When you write stuff out, it doesn't store it in memory, it will store it in the file. Okay. So, and all of these concepts, for everything we're talking about with Dask data structures, this is the same, except with a different data structure. So it will operate the same way for everything that we're going to talk about, apart from delayed, but we'll get to that. Okay, next up, bags. Now, bags are data structures for semi-structured data. So if you work with JSON or XML or text data, bags are a really good choice. When you read up on the Dask documentation, they say, oh, it's similar to a Python list. But I don't think it is. The API is very different, and you can do, it's better for me, for what we want to do with it, it's a lot better than the API for Python lists, though it can do all the stuff a list can do anyway. These are available through Dask Bag. So what we're doing here, we're importing some JSON data, and we import Dask Bag as DB. We read the text, and then we use Python's JSON library to map that to the data, and we can actually use the take command, which is like head for a pandas data frame. So you can use that to get the first n records. Dask bags, they're their own thing, and they're definitely geared towards JSON and semi-structured data. And they're really good for things like large-scale NLP tasks, web scraping at scale, working with huge JSON files and so on. And they're also really good for iterating as well, and we'll get to an example of that in a minute. You can read data in using read text, but you then have to apply a convention to that. So we saw from the example that we read the text in, and then we mapped it to JSON, so it was all nice JSON. Filter is like a where statement. So you're saying, well, actually, where the month is 2, only give me those records, which is really useful. That's not the kind of thing you can find in a Python list. And the map function is really good, and that allows you to apply a function to every element in the bag. So if you've got like 60 billion JSON records, you can map a function and have it apply to each one of those records. 2 text files writes out, flatten, which is really useful. If you've got horrible, long nested JSON, you can actually flatten the data structure that way. And you can also swap between data frames, Dask data frames and Dask bags really easily with the 2 data frame and 2 bag methods. So you can see that this is a kind of an overview of some of the stuff you can do. It's all geared towards working with data. You can't kind of add records, remove records the same way you can with a list, but it is a lot more relevant for the kind of stuff that we want to do with it. Now, I've got a kind of a demo here. So most of you will have used Pandas apply method, where you take a data frame, apply a function to it. That doesn't perform brilliantly in Pandas, and the same is true for Dask. As always, whenever you're working with Pandas, it's better to try and perform operations on columns rather than doing row-by-row iteration. It's a lot more efficient. And NumPy and Dask arrays can actually make that even more efficient. However, it's not always practical. Sometimes you've got a task where you have to iterate row by row. And that's what this example is. Now, I know there's a lot of many better ways to bin like data than writing a function, but it's, for example, purposes only. So here what we do, we read in a Dask data frame, we apply this function to every record, 102 million records in the Dask data frame, and then we write it out to a CSV. And that operation takes 27 minutes. Dask bags are a much better iterator. So here we're doing pretty much the same thing, except we convert it to a bag, and then we use the map to apply a delay binner function to the bag, and then write it out to text. And that runs 3 times as quick, which is probably, I don't know, 20 times as quick as you would do that in Pandas. So bags are useful, not only for JSON data, but they're also quite good iterators. And also, just to reiterate, we don't call compute because we're writing it out to text, and that computes the data anyway. So bags don't have a close Python or Pandas equivalent, although when you compute a bag, it becomes a list. They're useful for semi-structured data, and it's more efficient to iterate through a Dask bag than a Dask data frame. Now, when I passed this presentation over to a friend of mine who uses Dask a lot more than me, and he actually pointed out you can use map partitions as an alternative to apply on Dask data frames, which I wasn't aware of, so I put a little reference there. That's, if you do use Dask, that's something you might want to explore. And the same rules apply to Dask data frames as they do bags. And I can see there's a typo in my presentation. They're lazy and computation happens via set. And I have no idea how I've created that character. It's not a character that I would usually use. But yeah, computation happens via compute. That gives us a list. And only call, as before, only call compute when necessary. And writing out will compute the data, but it doesn't store it in memory. Okay, now possibly my favorite bit of Dask is Dask delayed. And the general rule with delayed, if you iterate over it, you can parallelize it with Dask delayed. So as I mentioned before, Python and Pandas are single-threaded, and that means they use a single CPU core. Dask data structures will leverage parallel processing for big data, and that all occurs behind the scenes. But Dask delayed has a different use case. So you've got a smaller amount of data, like 100 megabytes of time series data, for example, and you want to iterate over that. So you've got maybe, as I mentioned before, we've got 500 time series records that we want to iterate over. You can actually use Dask delayed for that. And in this example, we're going to be iterating over a data frame, but you can use it to iterate over anything in Python that you can iterate over. Lists, sets, dictionaries, etc., etc. So who here has used Facebook Profit? Okay, a few of you. Okay, Facebook Profit is, to give you some background, it's a really good for time series at scale. So you basically give Facebook Profit your data, and it works out quite a nice time series. It fits quite a nice time series for you. But it is quite slow. So it's a really good use case for us to actually say, well, actually, if we need to create 500 time series, we can parallelize that with delayed. And those kinds of processes, one intensive process that you need to repeat against lots of a grouped set of data in your data frame that's not big enough for a data frame or bag, and the process is single-threaded. Those kinds of use cases are perfect for delayed. So here we're importing and cleaning some the store time series data, and we limit the processing to 500 time series. And then, in order to parallelize it, it becomes really easy. So we'll create an individual time series, and what we're going to do is run this 500 times, both in Pandas and in Dask. And as we can see, delayed, the only thing we need to do to process that in parallel is apply the Dask delayed decorator on the function. And that will tell Dask, please run this in parallel. So when we time those, Pandas runs in 50 minutes, whereas Dask did it in 11, and that's 500 Profit time series. So if we wanted to do all of those, the all 1.7K that we had, Pandas would take about 4 hours, and I think Dask would have it done in about 40 minutes. So it's well worth doing when you're trying to process time series at scale, which is a problem we've had where we work. The only difference is, again, we have to compute the table. But aside from that, it's exactly the same code, just runs 5 times faster. So it's not, the thing about Dask delayed is that it's not as easy to use as the data structures, which are where Dask does a lot more kind of for you. So generally there is some do's and don'ts. Don't use large amounts of data. Try with the function that you're using to iterate. Pass a small chunk of data, otherwise it will just fall over, because if you pass like a 200 megabyte data set to it, it's just going to take all day while it passes that back and forth to itself. If you try and parallelize something that's already running parallel, it probably won't work. So a lot of Python libraries, for example, there's some geographic libraries that process in parallel. If you try and apply delay to those, your system just freezes up and it doesn't really do anything. So just be careful about what you apply it to. Definitely don't use Dask delayed with Dask data structures. They're two separate use cases, two separate things. If you try and combine them, it lets you do it, but you don't get a good outcome. I had to reboot my laptop when I tried it way back when. So if in doubt, if the data's large, just use Dask data structures. If the data's large and the processing takes time, still use Dask data structures. If you've got small data and the processing is taking ages and you've got something iterative, Dask delay is a great use case. If your data's not large and processing quick anyway, don't change anything. Okay, and that's true for all of Dask. It works best when it's got a lot to do. If you've got a small amount to do, you won't see any kind of speed increases. Okay, and we've just gone through that. Okay, last section of working with Dask is machine learning. And that's basically ML for data at scale, but it's not easy. It's not as easy as how Dask data frames work. So you can actually leverage Dask in a number of ways for ML tasks. You can use scikit-learn with a Dask backend. You can use Dask. There is a library called Dask ML that you have to install, but that's got a load of machine learning models that are actually optimized for use by Dask. And Dask, the Dask ML API doesn't cover all of scikit-learn. So it doesn't have stuff like random forest regressors, a few other bits and pieces in it. So if Dask ML doesn't cover it, you can use Dask data structures with scikit-learn, but they're not optimized and it will take ages. So just a word of warning. So using it as a backend for scikit-learn, so instead of running stuff on, say for example, running stuff through scikit-learn, you can parallelize with scikit-learn by doing -1. So you can parallelize scikit-learn processing by setting, if the algorithm you're using has an njobs keyword argument, if you set that to -1, it will process in parallel on your machine, which is really good. So scikit-learn will process in parallel anyway, but for more, you can also set up a Dask backend with joblib. So you just say with your Dask cluster, run this model, and it's of limited benefit when you're just working on your machine, especially when you've got, and if you can parallelize in scikit-learn, there's not a great deal of point to parallelizing in Dask. But the use case is, if you've got an external Dask cluster you want to run something on, you can use this method to do that. And in terms of performance, I actually found that scikit-learn parallelization ran quicker than doing it with Dask. It's probably slightly better optimized. So where you've got larger data structures, so you're using Dask data frames, you can use Dask ML. That's a really good use case for it. It doesn't ship with Dask, but you can install it via pip and conda. Really easy. It installs quite well. And it operates best on large data that doesn't fit in memory. So use it with Dask data frames. There's two ways you can use it. So the first is, it's got a load of models in the package. And if there's models in the package, then by all means use one of those. And it's also got the incremental wrapper. So what you can actually do is take a scikit-learn model with partial fitting, wrap it in incremental, and Dask will actually process that more efficiently than scikit-learn would. But the downside is the coverage of what scikit-learn offers isn't complete using these two methods. So this is an example of the first one. So the good news is it's got XGBoost. Hey. And we can import the XGB regressor and run an XGBoost algorithm on a Dask data frame. And it will actually process and compute that in chunks. And that actually performs really, really quickly. And the other way is and this is, so far, this is the only use case I've found for a passive-aggressive regressor, which is something I've been dying to use because of the really cool name. But yeah, the passive-aggressive regressor does have a partial fit method in it. So who knows what passive-aggressive regressor does? Yeah, I'm sure they've just made it up. But it does have the partial fit method, so we can use incremental with it. So to use incremental, what we'll do, it will train it incrementally, so it will train a chunk, then train another chunk, then train another chunk until it's finished. You just need to wrap it in the incremental class from Dask ML, and Dask will do the rest. So all in all, whilst Dask ML is really good and really easy to use, it doesn't have that full coverage of the scikit-learn API, which is really annoying. But I think the general consensus was that the way that some of these models are implemented makes them very difficult, if not impossible, to parallelize, and that's why you have only a few of them in there. So, your last option is to just use scikit-learn with a Dask data frame, and it will work, but it will work slowly. So if you've got a small, uncomplicated task, just use scikit-learn. If you have an external Dask cluster, if you're lucky enough to have one set up, you can connect to it and run a scikit-learn model via joblib. If you have a larger or more complicated task that is covered by Dask ML, then you can use that either through the Dask ML models or incremental. But if Dask ML doesn't cover your model, you can use scikit-learn with a Dask data frame. Okay, now this one, if you do plan on using Dask, I would say this bit is really, really important. I feel like I've done the sales bit about going through the API and talking about how quick it is, but you can run into pain if you don't configure your client directly. Now, at the beginning of the presentation, we just configured the client without any arguments at all. So you can do that and it will run, but that's not the optimal way of doing it. And I've spent this week doing a lot of trial and error, trying to find some optimal configurations for your Dask client for a local machine. And there are three keyword arguments that you need to give to the Dask client to have it run more optimally. There are n workers, which is the number of workers that you're going to use, and that should be in some way based upon the amount of CPU cores you have. Threads per worker, which is the number of things that a worker can do at once, and memory limit, which is the amount of your RAM available per worker. And you can find those details just with some of the libraries that ship with Python. So if you import multiprocessing, you can do CPU count, and that will tell you how many cores you have. And similarly, there's a little calculation here, which will tell you how much RAM you have. So on my machine, I've got 16 cores and 16 gigabytes of RAM. So when I'm working with Dask data structures, the limiting factor is my RAM. So I want to make sure each worker has a lot of RAM. So what I do, I take my number of cores and I divide by 4. I set the threads per worker to 2, and I divide the amount of memory that I have by the number of workers. And that gives me 4 workers between 1 and 3 threads per worker, depending upon the job, with a 4 gigabyte memory per worker. And that seems to work really well for me. Hopefully it will work really well for you as well, but I have no way of testing that. And to begin with, definitely keep n workers and memory limit the same. Just experiment with threads per worker. Generally, between 1 and 4 will work quite well. Now, for Dask delayed, you don't need, Dask delayed is a lot kind of a smaller functions that we're doing a lot more of. So you want to configure that slightly differently than when you're working with Dask data structures. So we take the number of cores we have, in my case it's 16, so it's 16 cores. Threads per worker we set to 1. And the memory limit, again, we divide the available RAM by the number of cores I have, so that's 1 gigabyte. And that will actually process, if you're using Dask delayed, this is a much better setup. And experiment with threads per worker, but always start at 1. How many threads per worker you can use is trial and error, but if you have a more complex process, like for example, importing profit, and using profit, then yeah, 1's probably a better shout. So that's everything I had to go through, and I think I'm largely on time, which is good. Woo. Don't use Dask for small jobs. when you're using Dask data frames, this wasn't something I had time to go into, but it works a lot better when you specify, when you import data via a CSV, you need to specify the data type of all your columns, and Dask will perform a lot more efficiently when you do. Alternatively, you can use Parquet files where it's specified in there anyway. Efficient Dask, if you use Dask locally, close other memory-intensive applications. So this week, I've been doing it a lot. It's been quite hot as well, so my machine has overheated and shut down a few times. So just be aware of that, and that's a particular problem when you're using Dask delayed, because all your processes are kind of firing at once a lot. And my Macs aren't great for airflow and keeping cool anyway. So hopefully you won't have that problem, but it's something to be mindful of. Efficient Dask equals efficient pandas. The same thing, just a different implementation. If you can write efficient pandas, that really helps with runtimes. And experiment with other stuff too. Like, there's so many, compared to a few years ago, there's so many more opportunities to do big data in an accessible way. So you've got Dask, you've got Spark, which you'll probably have to come across at some point anyway and have to learn it. But you've also got things like Ray and Vex, which are a bit more geared towards machine learning workloads. So you might decide that you want to use Dask for pandas and Ray to run your machine learning jobs. And that, that's fine. It's one of the tools that you've got available to you. Okay, we have a few minutes for questions, and I'm going to leave the QR codes to give you the link to the slides and the GitHub repo. GitHub repo is a bit of a mess, I'm sorry. I'm going to tidy it up today. But yeah, you'll have to aim so you get the right one. Okay. Does anyone have any questions? Am I in charge of picking people, or do you want to? Okay, yes. Who are you pointing at? I don't know. Yes, gentleman here, hello.
So my question was actually, you run it on your Macs. I suppose you have an SSD hard drive, right? But on the Mac, I suppose there should be as well the older one, the HDD hard drive. So have you perhaps experimented and seen any differences between the two, if the data is stored in one or the other in Dask?
No, but I would imagine that are you talking hard drives or RAM?
Hard drive,
Yeah.
I suppose that since you can upload it in memory, then it will read from this and
Yeah.
save to this. So
I
on SSDs would work very fast.
Yeah.
On the other,
It's probably going to be a lot slower when you're writing data out, and I suspect that it would run slower as well just in case it leaches any of your disk memory for extra RAM. So yeah, I haven't, but yeah, it's probably, if you do want to use it on your laptop, it's going to hit your laptop pretty hard. So yeah, I would try and maybe buy a new laptop. Hello.
I was going to ask, which laptop were you using? Was it an Air, and was it Intel's? Oh, right, okay.
Hang on, we'll get my.
Intel chip or the M1?
It's not the M1.
Okay.
I don't. Yeah, I haven't upgraded to the M1 yet because nothing works. That's my specs. So 16 cores, 16 gig of RAM, and it's I've played a lot of games on this, so it doesn't perform and it heats up. So if you get a new one, it'll probably be a lot. Hello, yes. So the tutorials used to be really bad, the documentation. They've revamped it and it's a lot better. But some of the examples aren't, like the delayed some examples aren't great. And I found it difficult to find good examples when I Googled. I know that they've got a GitHub repo with a load of Dask examples in that would be a good starting point. Hello, gentleman there.
Yo voy a hablar normal y tú ya vas controlando. Vale.
I don't know. I don't know. I think you're talking about the partitions thing I mentioned. Yeah. I think it's just the way in which Pandas works. It doesn't do that very efficiently because of the way it's set up. I know that the guy who uses Dask a lot said this is probably a better way to do it. So I would do it that way. And if that's not good enough, you can always move to a Dask bag as well. But it's the same problem in Pandas. And a lot of the time, instead of using apply, I'll convert it to a JSON and iterate through that way because it tends to be quicker. Yeah. Yeah, no, I'm not an expert on that, but yeah, it's irritating. Any more questions? Hello, yes.
Yeah, inside of Dask, is there any similar streaming processing or batch processing mechanism Dask.
Is there a batch processing mechanism?
Yeah, batch processing.
I don't know. I don't know the answer to that. I'm sorry. It's beyond anything lower level. I'm a bit API, yeah, but lower level I haven't focused too much on. I'm sorry. Cool. Well, thank you for your time, and I hope to see if you. I'll be around later, so feel free to come and call me if you've got any questions around Dask or anything data really. Thank you very much.